Hello, my dear student. Now we will discuss some more questions to check the correctness of the following relation. अगर आपको वीडियो अच्छी लगे तो इसको लाइक एंड सब्सक्राइब जरूर करें ताकि आपको फर्दर न्यू वीडियोस टॉपिक से रिलेटेड मिलती रहे. Now we will start to check the correctness of the physical relation and this time period of oscillating drop of radius r density rho and surface tension S is given by T equal to K root rho R cube upon S. Now on the left hand side, this is the time period and the dimension of time period is T. Now come to right hand side. On the right hand side, now we put root, put the dimension of density, rho is the density and the dimension of density is ml minus 3, radius L cube upon surface tension m t minus 2, रो की डायमेंशन एम एल माइनस 3, सरफेस टेंशन एम टी minus 2, radius L. Now this m cancel out. Now in numerator L power minus 3 into L power 3, now we add the power and shift T power minus 2 into numerator. So this is L power minus 3 plus 3 L power 0 into T power 2 and the square root of T square is T. So the dimension of left hand side is T and the dimension on the right hand side also T. So the formula is dimensionally correct. Now dimension on left hand side is equal to dimension on right hand side. Hence the formula is dimensionally correct. Now come to second question. The critical velocity of the flow of liquid through a pipe of radius r given by Vc equal to k eta upon में rho r. ये 2 नहीं rho r, where rho is the density and eta is the coefficient of viscosity and r radius. Now come to left hand side. Now we start the solution. On the left hand side, this is a critical velocity and the dimension of critical velocity is Lt minus 1. Now come to right hand side. Right hand side, K constant eta upon density into R. Now the dimension of coefficient of viscosity ml minus 1 T minus 1 upon density ml minus 3, radius L. M cancel out. अब टर्म हो गई ऑन द राइट हैंड साइड L minus 1 T minus 1 और डिनोमिनेटर में L पावर minus 3 plus 1. Now in numerator L power minus 1 T power minus 1 upon में L power minus 2. Now we shift L power minus 2 in numerator. So this term we write L power 2. इसको लिखेंगे हम L power 2 and now we write L power 2 into T power minus 1. L power minus 1 plus 2 into T power minus 1. So this is equal to Lt minus 1. Now the dimension of left hand side is equal to right hand side. Hence the formula is dimensionally correct. And right hand side Lt minus 1, left hand side also Lt minus 1. So this formula is dimensionally correct. Now come to next problem. The rate of flow of liquid through a pipe of radius r, pressure gradient P by rho is given by V equal to pi p r4 upon 8 eta L. where eta is the coefficient of viscosity. Now, come to the left hand side. Left hand side, this is a rate of flow of liquid. Rate of flow of liquid means volume per second. The volume per second time. Dimension of volume is L-cube. Time is T. So this is L-cube T minus 1. So the dimension of volume per second or rate of flow of liquid is L-cube T minus 1. Now come to right hand side. Pi constant, no dimension. P pressure. Dimension of pressure is ml minus 1, T minus 2. The dimension of radius is L, so this is L power 4 upon. Coefficient of viscosity ml minus 1, T minus 1 into length is L. M cancel. अब न्यूमरेटर में L पावर माइनस 1 प्लस 4 into T power minus 2. In denominator L power minus 1 plus 1 into T power minus 1. तो न्यूमरेटर टर्म होगी L क्यूब T minus 2 denominator L power 0 into T power minus 1. Now we shift add T power minus 1 in numerator. L power 0 1. So this is minus 2 plus 1. So this is equal to L cube T minus 1. Now on the right hand side dimension is L cube T minus 1 and on left hand side L cube T minus 1. So this formula is dimensionally correct. क्या लिखोगे? Dimension on left hand side is equal to dimension on the right hand side. So formula is dimensionally correct. Dimensionally correct. Now we will discuss one more question. The frequency of a string is given by nu equal to 1 upon 12 root T upon M. Where T tension, M is the mass per unit length, L length or new frequency. So on the left hand side, the dimension of frequency T minus 1. Now come to right hand side, 1 upon dimension of length is L into root. Dimension of tension is ml T minus 2 and this is the mass per unit length. So dimension is ml minus 1. M क्या है? Mass upon length और mass is m upon L. So this is equal to ml minus 1. Now this m cancel. अब आप इस L minus 1 को भी शिफ्ट इन न्यूमरेटर. तो 1 upon L अंडर रूट L पावर 1 और ये न्यूमरेटर डिनोमिनेटर को शिफ्ट करें न्यूमरेटर में. तो दिस इज आल्सो 1. So L power 1 plus 1 into T power minus 2. So 1 upon L, this is L square T minus 2. Now do the square root. So this is equal to LT minus 1. L cancel. So this is equal to T minus 1. Now the dimension on left hand side is equal to dimension of right hand side. Dimension of left hand side is equal to dimension of right hand side. So the formula is dimensionally correct. Right? क्या लिखोगे? Formula is dimensionally correct. So in next video we will discuss about to find the dimension of constant if formula is dimensionally correct. If you have any problem then you may write on comment box and तब तक के लिए आप ठीक खुश रहें, स्वस्थ रहें, हेल्दी रहें. Thank you.